Hi, and welcome back to Blockchain Fundamentals with Bill Laboon. Today we're going to discuss consensus. And when we discuss consensus, I actually want to go a little bit deeper and approach it from a different perspective than simply consensus on the running blockchain. Now, we will discuss several consensus algorithms. However, when we're running a blockchain, we're running a network, then there's actually different kinds of consensus, agreements that we want to agree upon. So the first, and what most people think about when they think about consensus, is what are the rules of the blockchain? How do we all agree what is a valid transaction or a valid state transition in the blockchain? What kinds of data will be sent from one node to another? How do we find these nodes? How do they communicate? The general rules of the blockchain. The other kind of consensus that when people discuss blockchains is what is the history? I mean, this is the whole point of having a blockchain, is that we have some canonical history that all nodes, or at least all honest nodes, can agree is the correct blockchain. And finally, consensus about value. What is the value of these tokens, or the cryptocurrency that you're using? Is there some sort of value attached to that? And if so, how is it determined? How do you decide that if I give you one Bitcoin, it's worth $9,500, or if it's worth $1, or if it's worth nothing? So all of these relationships, the consensus about rules and history and value, all of these are sort of intertwined with each other. So, for instance, if you can't come to a consensus about what the history is of the blockchain, you're going to have a lot of difficulty also understanding what the value of that blockchain is, especially what it has been historically. If there is no value, or people radically disagree about the value, they're probably also going to disagree about the rules of the blockchain. And if you can't come to a consensus about rules, you're not going to have much of the value of the chain. So first off, from a sort of less technical perspective, I want to discuss a consensus and value. So how do multiple people that are using a blockchain for some sort of exchange, some sort of purchase, or trading one token for another, how do they come to an agreement on what the value is? And I think the best way to go about this is to think, when somebody gives you $10 for a box of candy bars, for instance, why would you accept that? What is that $10 worth to you? Well, obviously it is worth more to you than those candy bars are. However, if you talk to somebody who doesn't like candy bars, perhaps they would not be willing to give you any money for these candy bars, or perhaps less than $10. And if you were to give this, if you were somebody that was starving, you haven't eaten for a week, then perhaps you wouldn't give up those candy bars except for $1,000. So we have this subjective concept of value already, and there's no difference in cryptocurrency. There are different people that are going to have different perceptions of the value of any cryptocurrency. However, we can't just throw up our hands and say, well, value is subjective, reality is subjective. We can never come to an agreement on what these Bitcoin or whatever are worth. However, there are some empirical solutions. I mean, so that you can try to determine what these coins are worth, to come to a consensus. So obviously, you could do it in a way that it is not mapped to price at all. It is only like to fiat money or any other thing. Simply that I have this one thing, you have this other thing, I would rather have that other thing. You'll see this often with testnet coins, and they're generally not really worth anything. People may collect them. These testnet coins are deliberately worthless. However, they might have some actual value in being used for like testing a network, for instance, or testing a distributed application or something. You could have pegs. So there are systems like Tether that try to maintain a one-to-one equivalency with the US dollar. There are similar, what we call stable coins, that try either algorithmically or via just via a declaration that they can be exchanged for a given amount of euros or Swiss francs or dollars or whatever. So we try to have a peg between our token and some real world value. This could be fiat currency, this could be gold, this could be something else. But perhaps the most commonly used is the first thing that I mentioned here. I apologize, I seem to have gone over my slide in reverse order here. Is some off-chain reference to what these coins are being traded for by others. So there are many different exchanges that will trade cryptocurrency for other forms of money. And using that, we can determine, perhaps by averaging this or having some agreed upon exchange that we take prices off of, to determine how we would map cryptocurrency prices to a more traditional currency. So there are a variety of ways that we can determine value. But most coins, while they may have some very small value, have some value, again, unless they're testnet coins or similar. So the second consensus I want to discuss is history. And remember, providing a canonical history is really what blockchain is about. We want to say what happened in order. If you remember back to when we discussed the time chains, that you could say that a document was signed on this day or this day or this day, and we could determine in what order it occurred in. So we have a lot of ideas on how this can occur, right? On how a canonical history is. But a canonical history is, by definition, a history of valid blocks. So you also need to agree on what are the rules on what constitutes a valid block. If you don't know what a valid block is, you can't say what a canonical chain is. And people may disagree on what the rules are for this, which means they may have very different ideas on what the canonical chain is. And this may seem very simple based on the general overview that I've given of how Bitcoin and other systems work so far. But just like any cryptocurrency, any blockchain function, really almost any program, is going to be changing over time. Bitcoin has the concept of Bitcoin improvement proposals. So these are minor changes, these are changes to the Bitcoin protocol that are proposed on different things that you can add to the Bitcoin protocol, or that might be added to the Bitcoin code itself. So you can do just a minor change if you notice that there's a typo in a comment somewhere or something very small like this. Then you can just make a pull request to the Bitcoin code repository. A BIP tends to be much more in-depth. There's going to be a lot of explanation of why you want to do that. The Bitcoin protocol changes very slowly. Bitcoin code changes very slowly. But officially, anyone can open up a BIP. You can try to propose that Bitcoin should include the text blah 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 in every single block from now on, or Bill Laboon rules, or something like that, or the hash algorithm should be changed from SHA-256 to some other hashing algorithm. That doesn't mean anyone is going to take it seriously. It'll probably just be closed and ignored, but theoretically anyone can do this. If you actually want to have your proposal taken seriously, then I would recommend that you, one, really consider what needs to be done. If you take a look at all of the previous, or at least many of the previous Bitcoin improvement proposals, and be prepared for long and drawn out and pedantic arguments. Most systems have some sort of improvement protocol if you'd like to make your own improvements. Ethereum has EIPs, and Cardano has CIPs, CIPs, Cardano improvement proposals. So this is even though Bitcoin sort of pioneered this concept, most networks will have something similar. So you've written a BIP, you want to change something, and you say, well, the developers are going to look at this. But when we talk about consensus, we need to think, who's in charge? Whose consensus do we actually care about? Well, we could say the developers. They're writing the code. They're the ones who determine what the rules are. So they're obviously in charge of Bitcoin, right? Well, someone else could say, well, miners are actually producing the blocks. They determine which transactions are valid. Theoretically, if miners ignored a transaction indefinitely, then we would never, that would never get into a block. So then miners are in charge, right? Or if they stopped working, then no blocks would be produced, and so they must be in charge. And someone else could say, well, no, users are in charge of Bitcoin because they decide, what consensus do they want to follow. If the developers create, this weird new strange aspect of Bitcoin, or decide to send all mining rewards go to the developers, well, users just won't use Bitcoin anymore. They'll start using some other cryptocurrency. So, well, users are in charge. Investors, people could say investors are in charge, right? They provide value for Bitcoin because they are actually purchasing it. If nobody ever did anything, ever invested their money in Bitcoin, the price would be much lower, and that means that miners wouldn't work, which means it would be much easier to attack the network. Someone else could say our merchants are in charge, right? No one is going to use a cryptocurrency if they can't use it for currency, if no one is willing to give them anything in exchange for it. So it's interesting especially in Bitcoin, and we see this in other networks as well, but I think it's most prevalent in Bitcoin. The very complicated mechanism, or very interrelated mechanism, may be a better word, on determining what the consensus is and being in charge of the network. So there's no real one person in charge. So if we think of this as as Bitcoin, Bitcoin Core, what most people think of as the canonical Bitcoin, there is no lead cat there, right? There's sort of all of these cats are sort of all heading in the same direction, and they do change places. And I think one of the reasons that Bitcoin especially has such a variety of stakeholders that have different concepts of what the network wants is that Satoshi Nakamoto disappeared, and so there really is no one person, no one dictator, or even soft dictator or figurehead for Bitcoin besides sort of the mythical Satoshi Nakamoto. And so while we do agree on rules, we actually see in Bitcoin has done very well in terms of maintaining a consensus going forward. We have seen some arguments over what is the future, what is the best way for Bitcoin to progress. And sometimes we even see that there are groups that agree strongly enough with each other that they and disagree with other sections of the network that they want to follow a different set of rules going forward. And so there's always the possibility of forking. So we saw that there could be temporary forks or chain splits, in any network, any distributed network, because one a set of nodes may see one block, and another may see another block as the next block in the canonical chain, especially if they're separated by, very, very far by distance. And so there may be temporary chain splits as different nodes agree on a different canonical chain, but generally these go away relatively quickly, and they are extremely rare in modern Bitcoin. They occur more often in networks with very small production time. You see forks, these temporary chain splits, more often in Ethereum with 15 to 20 second block times, or Polkadot with 6-second block times, simply because network latency becomes a much more important part of this race to produce the next block. You see this in Bitcoin with a mean 10-minute block production time, and very fast networks. You see this much less often. But beyond the chain split, when you have groups that really want to continue on different forks, they can always fork away. So this is a hard fork, right? So we have one group here. The red cats have decided to follow one cat and follow different rules, and the blue cats are going to follow this different cat. So up until the point of the split, they share the same canonical history, the same blockchain up to that point. But from that point onward, we can see that different groups are going to have a very different vision of history. And once this has occurred, and once this has occurred, you can't really reconcile these blockchains easily. There are some possibilities, but generally we now have two different currencies. So the red currency at the top and the yellow currency at the bottom will both agree on a history up until block 2. However, if you are running software for the yellow blockchain, you're going to see the 3B, 4B, and 5B, whereas for the red blockchain, you'll see 3A, 4A, and 5A as your history. And so if you are holding some of the blue currency, once this split occurs, you will have both some of the red currency and some of the yellow currency, because both of those are going to have the same history up until that point. Now, hard forks do not necessarily lead to a new currency. I just want to note that this is something that can occur, that you can form your own blockchain in this way. And some blockchains, in fact, hard fork quite often. So we do see Ethereum, for instance, hard forking occasionally to add new functionality. Monero, in order to avoid ASICs being produced to them, actually hard forks every 6 months to change the proof of work algorithm that they use to make sure that it's not economically viable to create ASICs for it, to help be a more ASIC resistant network. And similarly, network upgrades are not necessarily hard forks. So Bitcoin does what's called a soft fork. So it makes future functionality a subset of existing functionality, so that old nodes can continue working with the new blocks produced. Polkadot has an interesting system where the runtime state transition function, that is what explains the rules for how the blockchain works, is actually stored on chain. So you can actually change the runtime and change the state transition function without causing a hard fork, because you're just modifying some of the code on the chain that's stored on the chain. So if we see how this works in practice, for example, this Monero network upgrade, there is a rule change between block 2 and block 3A, and anyone who forgot to upgrade or hasn't upgraded to a recent version of the software, they might see block 3, but this is going to be ignored by the majority of the network. It is these are going to be orphaned, so everyone will ignore them. It is agreed ahead of time that they will be ignored. They just some users may accidentally continue on with this. So this right to fork and start your own currency, so either by just forking the code and making your own blockchain, or by building off the current blockchain, is extremely powerful because you're not held hostage, right? If you think you can do a better job, or you want to make some change in the rules, you can do that. And if you have enough people following you, you can create your own system. And in fact, we have seen this quite often with Bitcoin. So some major Bitcoin forks, there have been a lot of smaller ones. There was a Bitcoin XT, which the idea behind that was to increase the size of blocks from 1 meg to 8 meg. In order to do this, 75% consensus was required. This could be marked by whether or not you wanted to activate it. It was actually marked by setting a value in mined blocks. It had failed to activate. Bitcoin Classic launched in early 2016, ran for a little over a year. The idea was just to change 1 meg blocks to 2 meg blocks. They eventually officially folded and now support Bitcoin Cash. Bitcoin Cash, we'll discuss this a little bit more in depth in a moment. This forked in August 2017, and it's still by far the most popular Bitcoin fork. It has 8 meg blocks, and or it had at the time. It's now been upgraded to 32 meg blocks. So just here, I want you to notice that there were quite a few attempts here to increase the size of the blocks. And this will actually come into play momentarily when we just go more into depth on sort of the philosophy of Bitcoin Cash and its version of history as opposed to Bitcoin's. So there are two other forks, which both from Bitcoin, that replace the SHA-256 algorithm with Equihash, which is more ASIC resistant. Bitcoin Private also added optional anonymity, very similar to Zcash. So this is another thing. ASIC resistance was a very, very hot topic for a while. People that have problems with proof of work mining, especially in the centralization of it due to the need for ASICs to do it profitably. One solution obviously is to have ASIC resistant hashing algorithms while maintaining proof of work. Another system is to use proof of stake and avoid that proof of work entirely. So ASICs would be even less useful. So those were some of the major splits. However, really the only split directly from Bitcoin that still has a lot of use and is still a major player in the cryptocurrency space is Bitcoin Cash. So the disagreement here looks relatively, if you're not familiar with all the background, it looks relatively minor. So Bitcoin Cash did not implement a BIP for segregated witness, or SegWit, which basically moves some witness data to a different part of the block, and increase the block size from 1 meg to 8 meg. Bitcoin, or as some will call it, Bitcoin Core, did implement SegWit via a user-activated soft fork. We'll discuss that in a moment. And modified a block size limit to be a block weight limit. So a different way of calculating what the real size of a block is. These minor technical arguments, though, really paper over some more philosophical differences between Bitcoin and Bitcoin Cash. So I want to cover some of these differences. If you ever see Bitcoin and Bitcoin Cash listed, know that again, they had the same early history up until 2017, but they have really diverged in a lot of interesting ways based on the philosophies of the different groups. So Bitcoin Core really has one model implementation. So when you talk about Bitcoin, there generally is a single Bitcoin. If you want to run a Bitcoin node, there is a single piece of software that you will run. There aren't different implementations of it. Or rather, there are a few others, but they tend to defer to Core. If there is a difference in the consensus, they assume that they are wrong, and no matter what Core does is correct. And if you look at the number of nodes that run Bitcoin Core in Bitcoin versus others, it's, I don't have the numbers off the top of my head, but it's well over 99%. The vast majority of people running Bitcoin nodes are running Bitcoin Core, and there are good reasons for this. Consensus is very important, and very slight changes in consensus could mean a failure of the Bitcoin network, and so they have one reference implementation. Bitcoin Cash has several competing implementations. The idea here is that we all agree on the protocol, and we have strength in diversity by having these different developers and different implementations. We can make sure that if there is some failure in it, that there are other nodes that are failure in a single implementation, that there are other implementations that can continue to run. So we see here, as opposed to the vast majority of nodes being used by Bitcoin Core, we actually see quite a few Bitcoin Unlimited nodes, some Bitcoin ABC nodes, and a variety of other node implementations. So this is one difference between Bitcoin Cash and Bitcoin. I mentioned earlier this user-activated soft fork. So the idea here is that the users, the nodes, not the miners, create a soft fork. So they decide on what this what features they are going to support. So the idea is that if enough users do this, then the miners are going to want to follow the economic majority, the amount of people that are using it, the nodes that are using it. The miners don't want to be mining on some chain that others are going to ignore. So there are famous UASFs. This one, obviously, the introduction of SegWit, BIP 141, that caused the Bitcoin Cash Bitcoin split, but there have been others in the past, such as the introduction of the pay-to-script hash, BIP 16. So the second big difference that I want to cover between Bitcoin and Bitcoin Cash is really on how does Bitcoin scale. So there are a lot of different philosophies. There's a lot of different interesting arguments about this on either side, and I'm going to try to give a best definition and the arguments for each side. So really the difference you'll often hear referred to as the small blockers and the big blockers. So the small blockers are Bitcoin, and for scaling they really prefer second tier. So this means off-chain scaling, reducing the amount of work that is actually done on-chain. So this would be something like the Lightning Network, or off-chain distribution, or the Liquid Network. All of these are not directly interacting every single transaction on the main Bitcoin blockchain. Big blockers, on the other hand, are generally think that scaling should occur on-chain, usually by increasing the block size, thus named big blockers. That there will be it'll be simplest, and there will be the most possibility for scaling if we just make the blocks bigger. Now, of course, there are benefits and problems to this. The first benefit is that it's very simple, just increasing the block size, but it also causes some problems, since this means that the blockchain is going to grow much more quickly in size. So let's cover these arguments a little bit more in depth. So small blockers will say that increasing the block size might seem good now, but it's a temporary solution. as more activity occurs on the blockchain, you can't just keep increasing it forever. This also makes it harder for nodes to participate. Since if you, and we see this actually with other chains, running an Ethereum node, I can speak from experience, is more difficult than running a Bitcoin node because there's much more data coming in. It takes longer for it to synchronize. You need to have much more data storage, etc. So if it's harder to run a node, and if you want to encourage people to run their own nodes, then you really don't want to increase the block size that much. And if there are fewer people running their own nodes, this makes and more miners, as a percentage, will be running nodes, and you have centralized places that are running nodes instead of users running their own nodes. This makes making any of these future user-activated soft forks more difficult. Secondary scaling solutions are already available. So there is Lightning Network and Liquid and all of these other ways to scale without modifying Bitcoin itself. And if you do a hard fork on Bitcoin, which you would need to do in order to directly increase the size of blocks, this is a potential attack vector, right? This is something that is different than the way Bitcoin has worked in the past, which means that there are some things that we're not going to know on how it could work. There could be problems that we don't realize. Now, big blockers are going to turn a lot of these arguments around. If you have big blocks, the benefit, you're going to have more room for transactions, which means lower fees. This also means faster transactions. There have been times in the past when I've sent Bitcoin and it has taken several hours for it to finally get into a block, let alone be confirmed. Once it got into a block, I still had to wait 6 confirmations. So if we have bigger blocks, that means that there's less waiting. We'll have faster transactions. Secondary scaling is a point for centralization, that if you have these other chains, these can be centralized. They're not going to be as decentralized as Bitcoin. And that's also some additional attack or failure vector. Something could go wrong with the secondary scaling. And finally, they do admit that it will be slightly more difficult to run a node, but if more people are using Bitcoin, then more people because they can have lower fees and more transactions, then it will incentivize more people to run nodes, even if it's more difficult. So let's go back to the original source, Satoshi, and figure out what did he or she or they think about this. So the original Bitcoin didn't have a block size limit. And it actually was added in secret as part of another commit, which I find really interesting. I have a link to the commit up here if anyone wants to take a look at it. So the rumor is that even those who noticed it were asked to keep it secret. In the early days, there was the amount of transactions on a block, there was no way it was ever going to hit anywhere near the limit. However, this was generally seen as a simple anti-denial of service measure, so we couldn't have people just putting in tons and tons of dust transactions and clogging the network. We needed some limit. And of course, miners are probably going to avoid, if they have only a limited amount of space to put their transactions in, they're going to try to get the transactions that are going to give them more money. Or more Bitcoin. If you're just using dust to pay your transaction fees, then you're certainly not going to be picked up by these miners. So Satoshi did add it, but it seems like it wasn't really a consideration at first. So it really boils down this sort of a philosophical difference of what is Bitcoin. Was it a store of value? So this really is the small blocker argument. It's not the need, it's the need to have a functioning network that everyone can use and can be decentralized. Whereas the big blocker argument, and I realize I'm perhaps simplifying these a bit, is that Bitcoin is a means of exchange. It is a way of purchasing things. And if we make it easy for people to purchase things with it or exchange it, then we'll get more use out of it. Whereas the store of value would argue that you don't need to exchange things directly on chain for something to have value. Right? Or is it both? Is it a store of value and means of exchange? So this is there are a lot of different arguments over what Bitcoin is. It really is it was something really new when it came out, and I think people are still trying to discover what really is it from a societal perspective. So I realize I talked quite a bit about Bitcoin and the Bitcoin cash split especially, but this does happen in other systems. So perhaps the second most famous hard fork was Ethereum and Ethereum Classic. So in a few years ago, Ethereum had a smart contract called the DAO, and which had a bug in it, which allowed a hacker to drain a large amount of funds from the smart contract. And it was actually a significant portion of all the Ether in existence. So the question came up, what should be done about this? Should code be law, and that the hacker just did what the system let him do, and so they should get the this Ether? Or should these funds be somehow returned back to the people who had put them in? And the decision was made that these funds should be returned. However, a significant minority of the Ethereum community said, code is law. The hacker only did what the system let them do, and so we should continue the network from there. Without doing this. And so the Ethereum Classic chain is still running today. It had diverged from Ethereum years ago and is still running and has slightly different approaches, including their Ethereum is moving to Ethereum 2.0. Ethereum Classic is maintaining the proof of work. So another fork. And again, if you had Ethereum at that time, you then had Ethereum and Ethereum Classic. And there are other forks from other blockchains, some of which fork just the code and start their own new blockchain, some of which have forked the blockchain from a specific block. So finally, let's talk about what people think about when they talk about consensus algorithms. So there's one of the things, again, I wanted to cover is that there's a lot more to consensus than just consensus algorithms and just the computers, the nodes agreeing on consensus. So the two main kinds of consensus in blockchain are probabilistic consensus and provable consensus. So with probabilistic consensus, with Nakamoto consensus being the most famous example, that is how Bitcoin works, you're never 100% sure you're following the correct or the longest chain. Now you can be very, very sure so that it's astronomically unlikely that you are not, but you can never be 100% sure. So this is relatively simple to implement, but in its most famous form of Nakamoto consensus with proof of work, it's also very inefficient, uses up a lot of electricity, as we've seen before when we talked about proof of work. Provable consensus is more complex. It can be vulnerable to stalling, that is lack of liveness. It can't continue onwards at certain points. It may get stuck, something you'll never see with probabilistic consensus, most probabilistic consensus algorithms, but you can prove, to 100% you are on the canonical chain. You may not always know that you have the latest version of it, but you definitely know what has been approved by the network, and it will not change. So there are a variety of algorithms for this. The most famous and sort of the classic way to do this is what's called practical Byzantine fault tolerance. So a Byzantine fault, I think we discussed this earlier when we discussed the Byzantine generals problem, is some node that is either not responding or is malfunctioning or even actively malicious. And the PBFT is a classic solution to this. It works well with a small number of nodes that need to come to an agreement, where basically as long as 2/3 plus 1 of all the nodes are honest, the results are guaranteed to be valid. Uh, so so we can again prove, we can prove this mathematically that this will always be the case. The big problem is if a large number of these nodes drop off, then we could be vulnerable to stalling. Or if a large number are malicious, we could be vulnerable to stalling. And there are a lot of variations on this. So just a few I want to cover. Tendermint, which is used by Cosmos and was made to be much more performant than PBFT, but it's still vulnerable to stalling. So it prefers safety over liveness. It will, if it's not 100% sure that it can move forward in a safe way, then it just will stall. No further progress can be made. Casper, the friendly finality gadget, is used by Ethereum 2.0. And this is interesting. It prefers liveness over safety. So what we can have is like a slowdown of finalization. Grandpa, ghost-based recursive ancestor deriving prefix agreement, is used in Polkadot, which has a few interesting features past PBFT. It's based on Casper, but it allows very quick reconciliation after network partition. So if a large number of nodes drops off, then it can very quickly get back up to speed in finalizing blocks. And it's divorced from block production. So you can use any block production mechanism, proof of stake, proof of work, whatever. And even if it stalls, then since it's divorced from the actual block production can continue until the situation is fixed, enough nodes have come back online, etc., and can continue from there. So it sort of gives you the best of both worlds, but at the cost of quite a bit of complexity. So these are just a few of the different consensus algorithms that are out there, but hopefully I've given you a good overview of what we really mean by consensus on a blockchain. It really is more than just what people think of when they hear of consensus algorithms.